Hello students, myself Dinkar Satonkar again welcomes you in this part third of the chapter motion of 9th class physics. Let us recapitulate what we have studied in the part 2. In part 2 we have studied about the concept of distance and displacement. While discussing the distance, we have seen the definition of the distance as when a body moves from one point to another point or from one initial point to final point, the distance is the actual path length which is traversed by the object. So when the object moves from one initial point to final point, the actual path length which is traveled by the object, the actual path which is covered by the object, that is considered as the distance. While discussing the displacement, we have seen that when object moves from one initial point to the final point, the shortest distance between the initial and final point of the object is called as the displacement. While discussing the uh, differences of the distance and displacement, we have also seen about the unit of the distance and displacement is same, that is meter, but distance is a scalar quantity and displacement is a vector quantity. I already have told you about what are called as the scalar quantities and what are called as the vector quantities. Vector quantities are those quantities which requires the magnitude as well as direction to represent, and scalar quantities are those quantities which requires only magnitude for the representation. Direction is not necessary to represent those quantities. Those quantities are called as the scalar quantities. Now today in part 3 we are going to study about some examples where we can differentiate between the distance and displacement. And I told you that it's not necessary that distance and displacement are same. Sometimes it is quite possible that the distance and displacement may be having the two different values. So with some examples today we will try to understand uh, in some cases how the distance and displacement are the different quantities. Similarly, we are also going to understand what are the broad points of differences between distance and displacement. In order to understand the difference between distance and displacement, let's consider some examples before us. I have some examples put forward over here. We will try to understand how the distance can be represented and how the displacement can be represented. Let us consider that I have A as one initial point and B as one of the final point of the movement of the object. So let's imagine that during the motion of the object from initial point A to the final point B, let us consider there are various paths by which the object may reach from point A to point B. Let us imagine this is the path first by which the object may be reaching from initial point A to the final point B. Now there is quite possible that second path is also available over there by which the object may reach from point A to point B. There is path third also available by which the object may reach from point A to point B. So all these paths, when it is available, the object may travel from path 1, the object may travel from path 2, the object may travel from path P to reach up to the point final point, that is nothing but B. But when the object moves from, or the motion of an object is from either path 1 or path 2 or path 3, all these motion of the object, during this all these motions of the the object has the distance between A to B. But when I consider the shortest path, let us imagine that this green line is nothing but the path is the shortest path by which the object may reach from point A to point B. So this actually one and the only path which is nothing but the shortest path from initial point to the final point B is nothing but displacement of the object. So this is the quite possibility that there may be different paths by which the object may reach from initial point to the final point, but there is only one path by which it is the shortest path by which the object may reach from the initial point to the final point, and this shortest path is considered as the displacement of the object. Now let us try to understand with the second example which is I have shown over here, that how the distance and displacement, these two quantities, vary. So let's imagine that this is a straight line path where initial point is nothing but A, where the object starts moving from point A, and let's imagine that the object is moving in this direction. So these markings that I have shown over here, 1 2 3 4 and so on, let's imagine that these markings are nothing but the markings of the meter. So let's imagine that an object moves from point A, its journey starts from point A. So initially point A starts from the A, and first the object reaches up to this point B. So in this case, during this particular motion from A to B, the distance covered by the object is nothing but 15 meter, and displacement covered by the object is also nothing but the 15 meter. So in this particular case, when the object travels from point A to point B, the distance and displacement is nothing but the same quantity. Now let's imagine that object moves from A to B, and again, instead of stopping the object at point B, again it reverses back and it comes to this particular point C, which is an intermediately situated between this entire journey. Now in this case, the initial point is nothing but A and the final point is nothing but C. In previous case, initial point of the object is nothing but A and the final point of the object was nothing B. But in this case now, instead of this final point B, now object reaches up to the point C. So here C is nothing but the final point of the object. So if in this case now, if we want to discuss about the distance and displacement of the object, then the distance of the object can be stated like this. First, object starts from A to B, so I have to write here as distance is nothing but AB, plus now from B to C, object covered this much distance over here. So I have to add that much distance from B to C also, because the final point for this particular journey of the object is nothing but this motion of an object is nothing but up to the point C. So I must add these two quantities over here. So from A to B it is nothing but 15 meter, and from B to C it is nothing but 5 meter. So total distance, the actual path of the object from initial point A to the final point C is nothing but 20 meter. But if you think about the displacement of the object, then here this displacement is differing from this particular distance, because now this initial point is nothing but A and the final point is nothing but C. So what is the displacement? We have seen in the definition of the displacement, it is nothing but the shortest distance between initial point and the final point. So shortest distance is nothing but from this point A up to the point C, that is nothing but 10 meter. So in this case now, displacement of the object is only AC, although the object has traveled from A to B and from B to C. But here I have to consider A as an initial point and C as the final point. So because of this, AC is nothing but the magnitude of the displacement. So here displacement is only AC, and that is nothing but 10 meter. Now if you look carefully what is the distance and displacement, you will find that the distance covered by the object is 20 meter. However, the displacement covered by the object is nothing but having the magnitude of 10 meter. That's why in the previous part I told you it's not necessary that distance and displacement is same. Sometimes it is quite possible that the distance and displacement may vary from each other. Now let us try to understand one more example by which all the concepts of the distance and displacement will be cleared before us. It is not always necessary that the object may travel in the straight line. Sometimes the object may travel in circular path, sometimes the object may travel by taking the turn. So we have to consider in such situation how the distance and displacement can be calculated. So imagine that there is a circular track, and which I have shown it with the help of green marker pen. This circular track, on this circular track an object is moving. So imagine that A is nothing but the starting point from where the object starts its journey. So imagine that the object is moving, the motion of an object starts from the point E and it travels along the circumference of this circular track, and first it reaches up to this point B and again it reaches up to the point A. Imagine that the radius of this circular track is nothing but 14 meters. So imagine that this is nothing but the center of the circular path, circular track, and up to this point, that is nothing but this 14 meter is nothing but the radius. I am taking this as an example. This may be any different quantity. So I can say that the radius of the circular track is nothing but 14 meter. Now imagine that when an object travels from A and it reaches up to this point B. So when I say that the object travels from A to B, then in this case now distance and displacement are the two different quantities. Now here, when the distance of the object is considered, it is nothing but half part of this entire circumference of the circle. So now distance is nothing but this entire path which is covered by this particular object in a semicircular way of a circumference. So from A to B, if I want to calculate the distance, then I must write this distance is nothing but circumference divided by 2. Now why this is divided by 2? Because this is entire circumference. We are considering only half of the portion up to this end. That's why I have to divide it by 2. So this is nothing but 2 pi r. I know that the formula for circumference is nothing but 2 pi r. So 2 pi r divided by 2, this 2 gets cancelled and it comes out to be 44 meter. Now this is the distance covered by the object. But if you look carefully, and if I think it about the displacement of the object, then displacement, we have seen in the definition that it is nothing but the shortest distance between initial point and the final point. So here initial point is nothing but A and final point is nothing but B. So shortest path is nothing but this entire diameter of the circle. So this displacement, now if I make it 2 times of the r, so 2r will give me 28 meters. So if you look carefully along the circumference circular path, the distance covered during A to B is nothing but 44 meter. However, the displacement is nothing but 28 meter. Now if imagine that the object travels from A and reaches again up to this point A, then the distance covered by the object is nothing but the total circumference of this particular circular path. But since for displacement A is the initial point and A itself is an initial point, then the displacement would be 0. So these are nothing but the various examples by which the distance and displacement, variation in the distance and displacement can effectively be studied. Now let's come to the last part of this distance and displacement, that is nothing but distinction between distance and displacement. If you look carefully, then there are various points by which the distance and displacement differentiation can be formed over here. Now we know that distance is nothing but the actual path covered by the object. However, displacement is nothing but the shortest distance between initial point and the final point. Distance is a scalar quantity. Since it do not require any direction to represent, that's why magnitude is only sufficient to represent the distance. That's why it is a scalar quantity. However, for displacement to be representation, the magnitude along with the direction is also necessary. That's why displacement is a vector quantity. Now this point is important over here. Distance cannot be 0, okay, or it cannot be negative, but displacement may be 0, it may be positive, or it may be negative. While we have seen it in the previous example that in the circular path of the motion of an object when moves from point A and again reaches up to the point A, then the displacement will become 0. Okay, so in this case sometimes the distance may be 0, sometimes the distance cannot be 0 or distance cannot be negative, but sometimes the displacement, sometimes it will be 0 if the initial point and final point will be the same. Sometimes the displacement may be positive, sometimes the displacement may also have the negative value. Now distance is always greater than the displacement. This is also one of the important point. Distance is always greater than or equal to also, but it is never happens that displacement is neither greater than the displacement. It is either equal to or smaller than the distance. MKS unit system, the unit for distance is meter, and for displacement in MKS system unit for the displacement is also meter. So here ends our part 3rd, and distance and displacement concept is also over. So in next part 4 we will be moving ahead and we'll be seeing about what is called as the uniform motion and non-uniform motion, as well as a very important concept about what is called as the velocity. So see you in the next period. Till then, please go through these notes so that you will come to know it. Bye.